So today our objective is formal language and automata theory. Formal language and automata theory. Today I will describe about only for formal language, not the automata theory in this video. It will upload it shortly on the next one. So what is formal language? To understand language, we have to understand it. Just take in language. Let's say English. English is a language having some alphabets, having some words, some sentence. It is a language. So if I make a set, in this set, there the elements are the sentences. So okay. So in this theorem, in this subject, the formal language is the building block or the smallest unit is defined as symbol. So what is symbol? Just look into your keyboard. You can see that here is symbol like A, B, C, D and so on up to Z. Also in short A, B, C and short Z. Not only this, there is only 0, 1, 2 and so up to 9. Even some special characters like this also in this symbol part. So this is the basic symbol. After that we are coming into alphabets. So what is alphabets? From the symbol we have to make alphabets. Alphabets is nothing but set of symbols. What is this? This is set of symbols. Now the most important criteria of alphabet is that it must be finite. It must be finite. This is the most important criterion for alphabets. So what is the pure definition of alphabets? That is finite set of symbols. Suppose okay, this alphabet is given by the sign of sigma. This is the sign of alphabet. Now let's take alphabet using two symbols. Let's say A, B. This is an example of alphabet. You can also say like this is also alphabet. Okay. Why this is finite? In your English language or in your Bengali language or in Hindi language, is the alphabets are infinite? If they are infinite, you can't make anything or you can't do anything. It should be finite. Okay. These are two building basic blocks of formal language. Next thing is that string. What is string? To understand string, we have to understand alphabets. What is string? Okay. So the string is nothing but collection of alphabets. Collection of alphabets. So the second criteria is that it is not it may or may not be finite. It may be finite or infinite. Okay, fine. So let's see some strings using some alphabets. Okay, let's look some. There is alphabet is A, B. Now string. From this two from this alphabet, we can make a string like A. We can make a string like AA. We can make a string like AB. We can make a string like BB. We can make a string like AAA, AAB, ABA, and so on. So it is infinite. It may be finite. I am saying the example later. Okay, so what is the length of the string? 1. What is the length of the string? 2. What is the length of the string? 2, 2. And this is 3, 3 and so on. Fine. So this is nothing but string. What is string? Collection of some alphabets is called as string. Okay. After that we are going into our final thing, that is language. What is language? Language is nothing but what is language? Language is nothing but some collection of strings. Collection of strings. Let's check it. Let's take C language. In C language, to make a program, generally we use void main, open parenthesis, close parenthesis, and suppose int a, b, c, and so on, some lines. It should be known very clearly that these things are strings. So what is a program? A program is nothing but a string. A program is nothing but a string. Fine. This is the basic things of alphabets, symbols, strings, and language. Now we have to go into the deep. Okay. Let's take some examples. Suppose our alphabet is A, B, and we have to make a string where the first element is A. String 1, let's take the name. We have to make a string whose first element is A. That means that first element is A. How? So the element should be A, AB, triple A, double AB, and so on. So it is infinite set. It's an infinite set. Now go into a set. Let's take another example that a string S2 having length of 2. Length of 2. How you can make? Let's take A double A, AB, BA, BB. Okay, fine. So length of 2. This is the basic examples of string. You can make many examples from this, like the first element will be B, or you may also write that the first element is will be 3 elements. Okay, so let's take a nice beautiful example. What is this? Just take it. So if the question asks you that this is an alphabet and you have to make a string S1 having the length of 2. So length is 2. There are total 4 examples, right? AA, AB, BA, BB. Let's take a string S2 having of length 3. How you can make? Triple A, double A, B, and so on, 8 types. Total 8 types. This will be total 8 types. Yeah, nice. So when the number of elements is 2 and length is 3, you are getting my point, 2 to the power 3. When the number of elements are 2 and length is 2, that means 2 to the power 2 or 4. So this is a simple example. Many numericals or MCQ can be from this part. After that we have to go some basic things of set, or you may say that sigma, this symbol or alphabet. For any set, let's say set 1, 2, 3. For the order of set, we have to use this sign. This is nothing but the order of set. Or in mathematics, you can also give this O of set. This is nothing but the number of elements, 3. You can also use it here in this way. This is 2. Fine. Okay, these are basic thing. Okay, next I am going another thing, that is power of a set. What is this? Power of a set of power of a set. Suppose if my alphabet is this, if I make it 1, that means that, what is the meaning of this type of set? Okay, for this case, this is very first of all, this is a very important question for semester as well as in university purposes. So for this case, we have to know that set of in this, basically this power means that the string length or nothing but. This power means that the string length. Fine. So if it is sigma 1, then the string length will be 1. String length equals to 1. If it is 2, then the string length will be 2, and so on. If it is n, then the string length will be n. Okay. Now look at very carefully that for sigma 1 string length, right? That means the string length is 1. 1 means only one alphabet is there. String length is 2 means 2 alphabet is there without knowing the alignation. So the string length is 1. For this case, A and B. For sigma 2, the string length is 2. Look very carefully that two way of determining this. One is the way which is the guessing. By guessing that string length is 2, that means AA, AB, BA, BB will come. This is a way. Another way in our subject, or generally computer science engineers are working in this way. Sigma into sigma, this is into, okay. So sigma into that nothing but A comma B into A comma B in set. We have done it. So this is AA, AB, BA, BB. Fine. So this is power of a set. Another thing is that power of a set is null. That means this is null set, which is denoted by epsilon, or you may say epsilon. Okay. Our next topic is alphabet star, or you may say sigma star. Basically, in a set, general set, for a set, let's take U as a universal state. We have to take U as a universal state set. In this case, the universal set is this. Fine. So for this case, it is denoted in such a way, this, and so on. It is an infinite. Okay. Now I am coming a very beautiful thing, that is making of languages. And okay, let's take L a language. L is a language where the strings are starting with A. Strings are starting with A. It is not that L1 language is also a set. Okay, so this is a set. So L1 can be defined as in this way: A, AB, ABA, AAA, and so on. So this is an infinite set. Okay, let's take another language, L2, which is a set of strings having length of 2. So it will be like this way: AA, AB, BA, and BB. Fine. So you can see that what is sigma 1? Sigma 1 is nothing but having string length A and B. What is sigma 2? This is AA, AB, BA, and BB, and so on. Are you getting? Sigma 2 is L2. Okay. So let's take this as sigma star. In this sigma star, this L1, the language L1, the language L2, and you can make also many languages like L3, L4, L5, Ln up to L infinity. All languages are the part of this sigma star. Let's take L1 as a set, this L2, L3, and so on. These are the set of the universal set. So you can say that it is a subset of sigma star, or this also, and so on. This is the basic things of alphabet, symbol, language is done and exhausted. Okay. In the next video, we will describe about something of formal automata. Thank you.